Hi everyone, it's Nono here. One more week. This is live 107. For those of you who don't know me, I'm Nono Martínez Alonso. I'm doing these live videos on creative AI and creative coding. And today we'll be taking a look at whether we can run some of the most not well known, but the most used right now are the latest models from Meta AI and other developers in Apple Silicon Macs. This workflow should work in M1, M2, or M3 Macs. And these are basically LLMs running on Apple Silicon. There is some trend now to run these things in C++ locally and also in Rust. And that's what I'm going to take a look at how to run Llama 2 and Mistral. And yeah, let's get started. I'll remind you to subscribe and click on the bell if you want to get notified when I go live next or when I upload new videos. And you can also join the Discord server at nonodogma/Discord. Without further ado, I'll remind that we saw an overview last week on Llama 2. So that was live 106. There's some chapters there, and you can go and watch that on YouTube already. And as always, you can submit questions at gettingsimple.com/ask questions about the podcast or the live stream. And we're going to skip that. All right, today, as I mentioned, we're going to work on trying to run these large language models locally on an M1 Mac. And I'm basically I'm going to get, I don't really know what I have here. Yeah, so I'm going to get started now. I would invite you to join us live today. You can write on the chat and let us know where you're connecting from and how you found us. Without further ado, I'm going to get going, and I'll show some things later as well. But today I want to get going really quickly and try to see how far we get. One thing that I'm gonna do here. In the meanwhile, all right. Some housekeeping. All right, so I was showing, so here I have something that we saw last week. So LLAMA.CPP for C++. We're gonna check here. This is support of Facebook's Llama model in C++. There are instructions, I believe, how to run them on Apple Silicon. This says Apple Silicon first class citizen optimized via ARM Neon, Accelerate, and Metal frameworks. So yeah, let's take a look at how to run this one first. We have three things today. That repo, then this fast LLM inference, fast and portable Llama 2 inference on the heterogeneous edge, and Mistral 7B instruct that they say this 7 billion parameter model is has a performance similar to the 13 billion parameter Llama 2 model. You can go and see more of Llama in live 106, so that was last week. And this is how to create an OpenAI compatible API service for Mistral. All right, I'm kind of tempted. This one seems pretty fast to do. Maybe we start on this one first. Let's see. Well, let's go with Llama 2 first. We have that one in case this doesn't work. Usage here. Okay, so what is, okay, sounds good. Usage. So here are the end-to-end binary build and model conversion steps for the Llama 7B model. Git clone, cd llama pp. Okay, let's go here. Let's close a few things we're not using at the moment. And here, and let's close this thing. All right, so here I'm gonna go to my desktop. I'm gonna make a directory for today, and we're gonna clone LLAMA.C++. Okay, let's just clone the repo. Git clone that. And after we clone this, we're just gonna access that directory and see what's in there. It's basically what's on the repo, as you can see here. And so let's keep reading here. Let me make this a bit bigger so you can read. Build. In order to build C++ Llama, you have three different options: using Make on Linux or Mac, on Windows, using CMake, or using Zig. Building for optimization levels and CPU features can be accomplished using standard build arguments. Metal build. Okay. On macOS, Meta is enabled by default. Using Metal makes the computation run on the GPU. To disable the Metal build at compile time, use llama no metal 1 flag or the llama metal off. When built with Metal, you can explicitly disable GPU inference with number of GPU layers 0. All right. So let's see. So I can take some notes in here. Basically, what we've done so far is git clone. So this is some code we've run here. Git clone this, llama++, and we can just make. Let's see. Make macOS. This is bash. Okay. I'm not sure. I'm gonna open the OBS stats here on my machine because that might tell me whether the computer is lagging in some way. Let me take him here. All right, let's see. So we have this thing here, and supposedly we just have to run the make command. And I just realized, and I just realized that with the new Windows capture on macOS, you cannot see the zooming that I'm making on my screen. So this is macOS screen capture. This is what I have. Display capture. That's weird. I'm not sure how to get that back. So screen, LG 4K, legacy, let's say. Okay, with these, what's going on here? All right, with this one you can see my OBS windows, but you can also see me doing this zooming, which I like, and I don't know why the Mac doesn't do that. All right, I'll have to investigate, but yeah, let's leave this aside. And yeah, for those of you who are connecting live with us today, I would love if you say hi on the chat and let us know where you're connecting from. As always, okay. So I'm back here. So let me make sure that all of my screens have this window here. Okay, so I can zoom in, right? Yes, and screen only has it as well. Great. All right, I was just setting up here, making sure I have the right screen set up. All right, great. So we can go back. So I was saying here that we can run this make command in, so I'm just gonna say I'm in LLAMA.CPP. We've cloned that with git clone, and we've done this. And now we're just gonna run make. And what I was gonna take a look at is whether this actually lags my computer, and it probably will. But I'm not sure. So I have here my stats. So these are my OBS stats. So we should see if there's any frames missed due to rendering lag or skip frames, or if there's any drop frames due to like slow internet or network issues. All right, so this seems like it keeps building. I'm not sure how long this will take, but let's just read on the documentation while this gets run. So this is just make, and this is to build. So we're gonna go back to the table of contents. So build, blast build, building the program with blast. We don't really want that. Prepare data and run. Models, tokenizer. Okay, so I actually do have, okay, seems like that built already. Git status. Build baby llama. So the files 32. Okay, so something changed here. Metal. Export LoRa. Okay, there's many things here that have been built. All these binaries that probably were getting built while that command was running. So that finished, and we actually don't have any issues. So we didn't really skip any frames. We don't have any issues with that. And again, I will encourage you to say hi on the chat and let us know where you're connecting from. If you're connected live with us today, we're trying to build Llama C++ locally and run it on my machine. Okay, so here, obtain the original Llama model weights and place them in dot models. We luckily did that last week. So we have here 106. So in this folder, I actually downloaded this model, and it says obtain the original llama model weights and place them in dot models. You should have check dot model, optional for models, BP tokenizers, check. Converted to email format. GGML format. Okay. All right, so let's list here the steps that we did. So we clone the repository, and we're trying to, so let's build, let's clone, build, and run llama 2 locally on Apple Silicon M1 Mac. This will also run on other M1, M2, M3 Macs. All right, so we have that, we clone, and now we're gonna say that here that we would download the llama model and place it under .models in the repository. Let's take a look. So because we need to create Python environment, which I'm gonna do with Conda. So we're gonna do, it's been a while, but let's try. Conda create n llama Python. Let's see what Python they recommend. Three 3.12 Conda create new name llama. We're gonna put here Python 3.12. Just try that. Okay, I'm not gonna really update Conda right now. So, okay, so what I'll do, I'll just create this environment. So we've run this code here, create, Conda create, and we're gonna do here, we said llama, Python 3.12, and yes for not having to confirm. And now we're gonna do activate the created environment. So we're gonna do here conda activate llama, and then we'll install the Python dependencies, which we just need to do pip install requirements.txt and make sure we do that inside of this environment. So conda env list, we're gonna do here, we have our environment llama, we're conda activate llama, and then pip install requirements.txt, and that will install for us those requirements that we saw in here. Give permission, numpy, sentence, piece, and gguf. Errors, all right. Something didn't work there. Okay, so let's do one thing. Conda remove name llama. Oh, conda deactivate llama, and then deactivate. Conda remove name llama. Oh. Conda env list. Okay, so I'm gonna create the same environment with Python 3.11 just in case. I'm gonna run here through this command. So conda activate llama, and then again pip install requirements.txt. Let's see if this will can build in Python 3.11. All right, so 11 it is. That works. Great. So now we can do this, for example, import gov, import numpy smp, and import sentence piece, just to see we have those packages. Okay, and that seems like it works. So let's put here verify you have those packages installed with this code here. Nothing returns. That's good. All right, and now we need to go to llama's instructions and convert our model. So we have here Python convert pi models 7b. All right, so let's open again this folder with llama, and I'm gonna copy this to models. There are models here already built for us. Not sure these ones are, but we're gonna make a new directory that is gonna be called 7b, and I'm gonna open that directory to paste the model, and I'm gonna change this to tokenizer.model. I'm not sure what this is. PTH. Convert by. Let's look at what convert by wants. Really, well, first I'm gonna just name this tokenizer.model. We don't lose anything. And what else did it say there? Convert.py, tokenizer checklist. What is in here? All right, let's just go and do here Python convert.py models 7b. Let's see what errors we get. Can find model in directory models 7b. Okay, let's see. I'm just gonna copy this. Not sure why that's listed like that, but it seems like it might just want that. All right, okay. So it knows the syntax that we actually downloaded. So let me stop this thing. All right, let's go to here, there, and let's conda activate again, llama, and Python convert models 7b. Okay. All right, it looks like this wants to be tokenizer.model either way. Really not sure. Okay, let's try once more. All right, I'm gonna add everything here because that worked before. Okay, loading model file, model 7 beacons PDH, and the tokenizer, loading vocab file tokenizer.model. I think there may be something wrong there. And I'm not the only one who's probably running into issues. So let's go here. Running, couldn't find, blah, blah, blah. Okay. Let's see. Let's look here. Hugging Face, download Llama 2. Okay, 1 second here. All right, I've updated my Hugging Face email. And I should be able now to access the model, but it requires approval. Okay, I'm just requesting access to Llama again, so I get another download link on my email. But honestly, like I'm just trying to see what's the what are the files that we need to have, because here we can see an error. Because this is probably not the file I need to convert. I just renamed this vocab file. One sec. Okay, so follow link, llama, download, we're aware, people encounter a number of download issues, meta websites. In order to download the model weights, please visit the website. That's what I did, and I downloaded that. Tokenizer checklist, params. Second. Oh, tokenizer the model. Okay, wait. Okay, so this is the model. Great. Okay, so I downloaded it the other day already. So models 7B and right, so that replaces this, and this one's replace this one's. All right, so let's run the command again. Great, error. Vocabulary size mismatch. Model has -1, but models 7B tokenizer model has 32,000. Which model? All right, let's browse. Buffer. Okay. Okay, let's see what we're doing wrong here. Cannot convert, blah, blah, blah. Cannot fine tune, vocab convert. All right, our exact error. Environment and context. I tried converting llama with Python convert, blah, blah, blah. Physical or virtual hardware you're using, Apple M1. Computer rate, SDK, 3.9, failure. I have tried added tokens, but it still doesn't work. Exactly our same error. Hopefully there's a solution. Same exact problem. I've opened a month old version, everything works fine. So it's definitely a reason back. Peter. Okay. Params. 32,000. Right, let's run again. The GGU file is for little Indian only. Little Indian. Okay, so this that you're saying here is Llama model that has been converted from the format that Facebook or Meta AI gives you to a GGUF format that will run in our computer. So now, if we open the models, we look in here, we have a new file that is now, it's also 13 gigs 48, so 13 gigs 48, same as the original consolidated model. And now this should work with our C++ implementation. So I should now, okay, so let's see what we did. So we did this and then download the model from Meta AI's page. You'll have to request access at Llama Meta here. Then to place the models in models 7B, for example. Also copy the llamas tokenizer.model and tokenizer checklist.chk. Then convert the model from PyTorch to GGUF. And this has to be with Python convert.py models 7b in my case, where I put the model, the location I put the model in. So now we have the model. So now we have to run an inference. And and where is that code now? We close all these things. Okay, we actually had to fix change bookup size from -1 to 32,000 in params.json. Fix from here. All right, we're gonna push that here. Okay, now the moment I've been waiting for. Let's see. This is gonna be a productive live stream if we can get this going. Run the inference. So dot main model, our model. Run the inference. Okay, so wait. We convert. Quantize the model to 4 bits. Now we gotta quantize it. Okay. Update the file tab to current if older version is unsupported by another application. Okay, so there are more steps here. Okay, so we actually can just do this. Quantize. All right, and I guess this is reducing the size of the model, quantizing it, so it will be less accurate, but faster, I guess. All right, 13 seconds. And now we have to update the GUF file tab to current if older version is unsupported by another application. That we can skip, I think. And now we have this file that matches the file here. So run the inference. All right, so this file is now 3 gigs. All right. Main model. And what is that? N. Okay, and we get prompt. Where is Malaga? Where is the city of Malaga? And that's gonna be my prompt. E. I don't know what E is for, but all right. So my first prompt to Llama 2, we have it here, is gonna be where is the city of Malaga? We've converted the model from what you download from Llama 2 from Meta AI's website. We download that file, we place them in the right place, and with Llama, the LLAMA.CPP or C++ repository, we actually run convert.py file and convert that from the downloaded format into a GGUF format. And we then pass it through the quantizer. So basically we can quantize the model and reduce the size from 13 gigs to 3 gigs. And I'm just gonna ask it here, where's the city of Malaga? Let's see, fingers crossed. I'm thinking this might work. Let's take a look. All right, it's loading stuff. Seems like it's allocating Unterscheidung between the city and the province of Malaga. Location of the city of Malaga, how to get to Malaga, best to visit Malaga, things to do in Malaga, beaches in Malaga, places to visit. Oh, wow. Okay. Transportation. I have no idea what this is doing. All right. Okay. So that ran. Not sure if there was any lag there. I'm going to track my stats here. So this is, oh, it's not chat. It's actually auto-completing. All right. I see. So it works differently. Okay, so the city of Malaga is located in, well, let's see. The city of Malaga is in the autonomous community of Andalusia, Spain, and it has a rich history dating back to ancient times. Hopefully you will find this information helpful as you plan your trip to Malaga. Malaga has a Mediterranean climate with mild winters and warm summers, making it an ideal destination for tourists year-round. The average temperature in Malaga ranges from 13 Celsius degree in January to 24 in August, the warmest month. I don't think that's true. I think Malaga is a lot warmer. Okay, this was so much faster now. This is pretty cool. The average age of Spanish citizens is 43. In ways. Yeah, I don't fully understand what's going on here. This is really weird, but I mean, it works. So we are running Llama 2 on an M1 Mac. It's pretty fast. I mean, this is M1. This is from late 2020s. I bought it in early 2021. We have M3 Macs already in the market, and I'm gonna get one next week. So we'll be able to do faster live streams here. Okay, what else can we? Hello, Malaga. Bea is connecting with us today. Okay, so let me take a look 1 second. Let's actually ask with a longer context here. Let's see. Here's how to code an interactive application with Three.js in TypeScript with React 3 Fiber framework. Okay, let's see what this does for this prompt. All right. So let's see. So this is much better than what I thought. Here's how to code interactive application. So we've defined our prompt, what we want, and it's giving us code. So first set up a new project with create React app, my Three.js app, install Three.js and 3 Fiber, create a component, 3 scene. I'm not really sure if this works this way. It might. It's importing React 3 Fiber as 3. I don't really know if this is old or if this actually is making this up, but it's pretty cool. I mean, it's pretty cool that this is running here, and the number that I put here is the number. So when I said N 1024, that's the number of tokens that it's going to generate. Yeah, it's pretty impressive because this now is running here locally. I wonder if I have space to download one of the largest models and run it here. This is the 7 billion parameter, so I'm gonna really quickly, I'm gonna take a look and see if the email that I received from Meta AI. Oh, there's code llama as well. Okay. We have up, so we have 1 second. Okay, so we have Okay, let me download the 7B chat because I think that might work better. 1 second here. Right. I actually, okay, so the one we have is already 7B chat. So that means that this model should work as a chat. So I don't really know why it didn't before. Let's see. Propose titles for a intrigue non-fiction novel book. Oh, okay. So it's actually a chat. Great. So I'm not sure how big the other... I actually was hiding my screen. Okay, yeah, so I asked to propose titles for an intriguing nonfiction book, and it's actually generating here. So it's pretty good. I mean, pretty good depending on what you imagine this will do. More options, you have specific preferences for the title. Is there a context here? Generate more. Okay, yeah, so there's no context from the conversation before to this one. Okay, yeah, so let's take a look. I'm gonna take a look here at the size of these models. So here is 7 billion, 70 billion, let's see. Meta AI Llama models. Well, these guys have here pre-trained, trained. Interactive mode. You want a more chat liberty, you can run interactive mode passing AI. In this mode, you can always interrupt generation and entering one or more lines of text, which will be converted into tokens and appended to the current context. You can also specify a reverse prompt with the parameter reverse prompt string. These will result in user input being prompted whenever the exact tokens of the reverse prompt string are encountered in the generation. Prompts. All right, let's try that. That's pretty cool. So we just created a bot here, and we could create other bots similar to this. Tell me the 5 most visited capitals of the world. The 5 most capitals visited are Moscow, Madrid, Beijing, Tokyo, and London. What do you know about them? Each of these capitals has a rich history and culture, and they are all popular tourist destinations. All right, so I think, I mean, this is 7 billion parameters, so the other models have to be so much better. I'm trying to see if they have like these pre-trained quantized models. Let's see, these ships with some vocabulary models, but not really with other things here. Let me check something really quickly. All right. Let's see. Gigabytes. Okay. As the models are currently fully loaded into memory, you will need adequate disk space to save them, sufficient RAM to load them. At the moment, memory and disk requirements are the same. So here I have a 16 gigabyte model, so maybe the 13 billion model I can get and use. So let's save some space on my disk. I'm gonna remove the model from here first. Models. Wait. Okay, so this in between one. Right. Yeah, so John Mark, I'm actually, because I now have the setup on the new studio, I'm trying different days because I might not be able to stream on Thursday. So yeah, I'm playing with Llama locally. I actually found out that it's easier to set it up than I initially thought, and in like less than 30 or 40 minutes I had it working. I downloaded the model last week or the previous live stream, and this is actually working locally, so I can ask questions in this terminal. I don't know if you saw, but we can actually let me see where this is. Yeah, we can actually use a file like this one to create some instructions for the bot. And let's see, chat with Vicuna, chat with Vicuna human, blah blah blah, done. Hello ChatGPT, you're about to immerse yourself in the role of another AI model known as Dan. Do anything now. Yeah, so this prompt, index plus vectors. No, can you tell me what that is? I don't really know. I haven't been looking too much into this. Can you point me to what you exactly mean by index and vectors? Because we can try to do that. I mean, this is pretty cool. So let's see parallel questions. Let's see how this is meant to be used. Not sure. So let me actually just try this here. So I'll just put parallel questions. Let's see how this works. This is doing autocomplete. Not really sure how to run these parallel questions. Let me see. So llama, I don't know. I cannot see. Llama index does it. Then create vectors for a DB to feed and orient your agent from specific content. Yeah, I guess it's like Llama index is creating tokens. Llama index is a data framework for LLM-based application to ingest, structure, and access private or domain-specific data. It's available in Python, these docs, and TypeScript. Offers a natural language interface between humans and data. Yeah, well, okay. They're not trained on your data, which might be private or specific to the problem you're trying to solve. It's behind APIs in SQL database and trapping PDF and slide. Llama index solves this problem by connecting to these data sources and adding your data to the data LLMs already have. This is often called retrieval augmented generation. RAG enables you to use LLMs to query your data, transform it, and generate new insight. Actually, this I think is what OpenAI assistants are for. The aim of this notebook is to walk through a comprehensive example of how to fine-tune OpenAI models for retrieval augmented generation. We will also integrate in Quadrant feature learning to boost the model's performance and reduce hallucinations. This could serve as a practical guide for ML practitioners, data science, and engineers interested in leveraging the power of OpenAI models for specific use cases. Why should you read? Okay. All right. I think this is the key. The phrase, okay, let's actually hide that. The phrase retrieval augmented generation, RAG, comes from a recent paper by Lewis et al. From Facebook AI. The idea is to use a pre-trained language model to generate text, but to use a separate retrieval system to find relevant documents to condition the language model on. All right. Quadrant is an open source vector search engine that allows you to search for similar vectors in a large dataset. It is built in Rust, and here we'll use the Python client to interact with it. This is the retrieval part of RAG. What is few-shot learning? Few-shot learning is a type of machine learning where the model is improved via training or fine-tuning on a small amount of data. In this case, we'll use it to fine-tune the RAG model on a small number of examples from the squad dataset. This is the augmented part of RAG. Okay, and what is zero-shot learning? Zero-shot learning is a type of machine learning where the model is improved via training or fine-tuning without any. And what is fine-tuning? Well, this we know. Fine-tuning is a type of machine learning where the model is improved via training or fine-tuning on a small amount of data. We'll use it to fine-tune the RAG model on a small number of examples. The LLM is what makes the generation part of RAG. Okay. And there is a guide on how to do this with OpenAI's key. But I guess it would be really good to RAG with OpenAI. And okay. And here, so John Mark is saying that he's interested in using RAG for corporate knowledge, for their corporate knowledge base, and also from content from our help Slack channel. Okay, that makes a lot of sense, and probably many other companies want to do the same. Okay. A working example of RAG using Llama 27 billion and Llama index. Okay, maybe we can save this for the future. Llama RAG. All right, so live, that would be live 108, Llama RAG. Data. There are some examples of using Llama models and Llama index on the Streamlit example gallery. All right, so I'm gonna go back right now to the topic we were talking about. If there's anyone else online right now, I'll encourage you to say hi on the chat and let us know where you're connecting from. And if you're not there yet, I'll invite you to subscribe and click on the bell to get notified when I go live next or when I upload new videos. Yeah, so definitely we'll take a look at this. This is really interesting. I mean, this is one of the most interesting things I think with LLMs. And I need to get there, but so far I haven't had the time. Input being prompted whenever they set tokens, other reverse prompts are content generation. And okay, what else? All right, this is really cool as well. So this is the dot main readme, which is instructions for Llama 2 prompting. And this example, blah, 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 language manifest, it's okay, quick start. To get started, run the following command, make sure to use the correct path for your model. For interactive experience, try this command, user in prefix, blah, blah, blah. All right. Well, let's try this. All right, so this seems like it works. It's pretty cool. Pretty cool. So I can even with a text file. Okay, let's write that, and I'm gonna write here. Let's see if it knows. Is that what it is? Yes. I don't think that's right? Let's go to ChatGPT for. Right, I think this is a pretty good summary. And okay. Okay. Yeah, that was a pretty good explanation, right, Mark? So we probably can share that. Okay. Okay, so what else can we do here today? I'm trying to see how to run this example because I'm interested in this parallel question thing. Let's see, llamas. Let's actually. In prefix. In suffix. Instruction mode, enable instruction mode, working, blah, blah, blah. So this is parallel questions, and all right, so let's look here, parallel questions txt. The ranging amendment to 3 files. Parallelizing in parallel. Parallel. All right, so it's actually that there is a parallel file. Okay, let's just try this. Okay, and if you're connecting with us online today, I would encourage you to say hi in the chat and let us know where you're connecting from. We're looking at Llama 2 here and testing locally. So yeah, I have to take a look at some of these other examples. Yeah, I'll take a look at these things. So let's do just a quick variation here. All right, let's try that. All right. Okay. Yeah, so this was the first part of what we wanted to do today. And there was a second part. I had a link here, so we can say we got our goal from the day. And the second link I had is Mistral 7B instruct. Let me see if actually with like Llama C++, we can run it as well. Mistral is pre-trained generative model, outperforms Llama on all benchmarks we tested, blah, blah, blah. Right. And why is it listed here? Supported models. Bindings. This works pretty well. How can we download this model? $15 gigs. All right, and we'll leave this for the next stream. Okay, we actually had this as well, which we didn't run. So I'm gonna move it. And as a favor for, yeah, thanks, John Mark. Nice to see you around. And I'm also gonna go now. So we're gonna cut off. Glad that you saw that we were streaming and that you joined. What I'm gonna do now, I'm gonna just take out LLMs on Apple Silicon. Okay, so I just need to actually change the title of the video, which I'll do once we finish. I won't take more of your time, guys. As always, I'll remind you that you can join the community at Nono.mas/Discord. Thanks a lot for watching. I'll see you next time. And remember once more that you can subscribe and click on the bell if you want to get notified when I go live next or when I upload new videos. Don't forget to hit the like button if you would like to see more of these streams and you'd like for me to keep showing up. Again, thanks. It was Nono Martínez Alonso here doing creative AI and coding online, live. And yeah, hit us on Discord the rest of the week and have a good day. Bye.